Today, we're going to unpack a powerful way of thinking that can solve even the most bizarre problems. I'm talking about things like a car that seems to be allergic to vanilla ice cream. It's called computational thinking, and trust me, it's a mental toolkit you're going to want to have. Okay, so get this. This is one of the strangest but totally real customer complaints in automotive history. A letter was actually sent to General Motors with this exact problem. I mean, think about it. A Pontiac that won't start only when the driver buys vanilla ice cream. It sounds absolutely insane, right? Like, where do you even begin with a puzzle like that? So this whole vanilla ice cream mystery, that's going to be our main case study. We're going to follow the story of this one GM engineer who, against all odds, decided to take this bonkers complaint seriously. Now, you can just imagine what this engineer was thinking. He had to assume it was a prank, right? But something about it made him curious. So he actually went out to meet the car owner. And when he got there, he found this well-educated, successful guy in a nice neighborhood. And he realized, oh, wow, this isn't a joke. The problem was 100% real, and now he was on a mission to figure it out. So the engineer decides to go along for these nightly ice cream runs. Night 1, they get chocolate. Hop in the car, turns over, no problem. Night 2, they get strawberry. Same thing, starts right up. But then, night 3, they buy vanilla. And wouldn't you know it, the car fails to start. Just like the man said. The complaint was real. The mystery was not only real, but it just got a whole lot weirder. Okay, so when you have a problem this out there, the usual approach isn't going to cut it. The engineer knew he couldn't just look at the spark plugs or the engine in the normal way. He had to change his whole way of thinking. He needed a new, structured approach to get to the bottom of this. And that brings us to the star of our show today, computational thinking. You know, it's the exact process this engineer used, even if he didn't call it that at the time. It's basically a method for taking a really complex problem, understanding what's really going on, and then coming up with possible solutions that are so clear a person or even a computer could follow them step by step. And let me just be super clear about something, because it's a really common mistake. This is not about trying to think like a computer. Honestly, computers don't really think at all. They just follow instructions incredibly well. Computational thinking is a framework for us, for humans, to think better, to figure out problems and design those clear instructions in the first place. So this whole way of thinking, it really stands on 4 key pillars. We're going to call them the 4 cornerstones. All right, so here they are: decomposition, pattern recognition, abstraction, and algorithms. Let's break down what each of these means, and we'll keep using our vanilla ice cream mystery to see them in action. First up, we've got decomposition. This sounds fancy, but it's super simple. It's just about taking a giant, overwhelming problem, like why is my car allergic to vanilla ice cream, and breaking it down into smaller, much more manageable parts. Think of it like trying to eat a whole pizza. You don't stuff the whole thing in your mouth. You cut it into slices. And this is precisely what our hero engineer did. He started breaking the problem down. He started taking detailed notes on everything he could think of: what time of day it was, the type of gas in the car, exactly how long the drive took. He even looked at the layout of the ice cream store. He was creating all these little mini puzzles to solve instead of one giant one. Okay, cornerstone number 2, pattern recognition. So once you've got all those little pieces from decomposition, you start hunting. You're looking for similarities, for trends, basically for anything that happens over and over again. You're trying to find the signal hidden in all the noise. And bingo, this is where the engineer has his big breakthrough. As he's looking at all his notes, he spots it. He finds the pattern. The trips to the store when they bought vanilla ice cream were always consistently shorter than for any other flavor. That was the aha moment, the first huge clue that maybe, just maybe, this had nothing to do with the ice cream itself. All right, next up is abstraction. This is all about filtering out the junk. It's the art of figuring out what's important and what's just irrelevant detail. You're ignoring the stuff that doesn't matter so you can zoom in on what truly does. Let's use an analogy. Think about the concept of baking a cake. At a high level, what do you need to know? Well, you need to know that a cake requires ingredients, that those ingredients have quantities, and that it needs to bake for a certain amount of time, right? For that big picture understanding, you can totally ignore which ingredients or what quantities. You're focusing on the general rules, not the specific recipe. So back to our car mystery. The engineer does this brilliantly. He uses abstraction. He realizes the flavor of the ice cream, vanilla, chocolate, who cares? that was all just noise. It was an irrelevant detail. The important thing, the pattern he found, was the time. So the problem wasn't about vanilla. It was about how fast the trip was. And that brings us to our fourth and final cornerstone, the algorithm. I know, this word sounds super techy and intimidating, but it's not. An algorithm is just a simple, step-by-step plan for solving a problem. It's the recipe you create once you've done all the other work. The decomposing, the pattern finding, the abstracting. It's your clear-cut solution. So, what was the final algorithm? The step-by-step solution to our mystery? Well, here it is. Step 1, vanilla is the most popular flavor, right? So the store, being smart, put it in a separate freezer right at the front to make it easy for people to grab and go. Step 2, this meant buying vanilla was way faster. Step 3, because the trip was so much shorter, the car's engine didn't have enough time to cool down from the drive. And finally, step 4, this led to something called vapor lock, a condition where the engine is so hot that the gasoline turns to vapor in the fuel line and the car can't start. It was never about the ice cream. It was about engine temperature. Case closed. Now, as cool as that story is, this way of thinking is for way more than just weird car problems. This is a fundamental human skill that's been used to tackle some of the biggest challenges in history. Think about this. During World War II, long before we had fancy computers, code breakers were basically human-based computers. What did they do? They decomposed mountains of enemy messages. They searched for patterns in the seemingly random letters. They abstracted the core rules of the ciphers, and then they built algorithms to crack them. They were using computational thinking, and their work literally helped change the course of the war. And what's really cool is that you already do this, probably without even realizing it. I mean, think about something as simple as planning to meet a friend. You decompose the problem. Where am I? Where are they? How can I get there? You recognize patterns. You know, traffic is always awful around 5 p.m. You use abstraction. Is the best route the shortest or the fastest? And then you create your algorithm, the turn-by-turn directions you'll follow. See? You're already doing it. So the point is, this isn't some secret skill reserved for programmers. It's a problem-solving superpower, and it's one that you already have. And if you take away just one thing from all this, I hope it's this quote. Computational thinking is about conceptualizing, not programming. It's about the human part, the creative thinking and problem solving. Writing the code, that's just translating your solution into a language a computer understands. The real magic happens in your head. So, I'll leave you with a question to chew on. What's your vanilla ice cream problem? What's that big, messy, complex challenge in your life, at work, at home, anywhere, that you could start to solve by just breaking it down with this framework? Think about it.